Okay, we have AP Physics 1 past paper 2015. We are discussing the section free response questions, section 2, and we have the question 2 which carry the 12 points. Some student wants to know get up use the incandescent light bulb when it is in series with the resistor, current, energy or the both. They come up with the following two questions. First question, in 1 second, do fewer electrons leave the bulb than the enter the bulb? For second question, does electric potential of the electron change while inside the bulb? Okay, these are the two main questions we have to find the answer. Now, the question asks the student have adjustable power source, insulated wire, light bulb, resistor, switches, voltmeters, ammeters, and other standard lab equipment. Assume power supply and voltmeter are marked in 0.1 volt increment and the ammeter marks 0.01 ampere increment. Part A question. Describe the experimental procedure that used to answer the question 1 and 2. Both we have to reply these two answers. We have to make then experimental procedure. In your description, state the measurement that would make and how would you use the equipment to make, including neat leaf diagram. Okay, we have experimental setup. First, we have designed the experimental arrangement. We have the power supply and the ammeter before the bulb and ammeter after the bulb. This is in a series. Then in a parallel combination, we have a voltmeter across the bulb and the resistor in a series, and there is a key to stop or on and off the apparatus. Up now adjustable power supply is in series with the fixed resistor, light bulb, ammeter before and after the bulb, and voltmeter parallel and a key. Okay. Place first ammeter, measure the current entering the bulb. We come to know from this how many charges are entering into bulb. And the second ammeter bulb show negative terminal current leaving the bulb. This ammeter will tell us how many charges left from the bulb. Connect voltmeter in a parallel, that will measure the potential difference. How much energy this bulb is consuming is we come to know from this voltmeter. Close the switch to turn the circuit. Switch key will on and off used to and allow the bulb to stabilize. After a few seconds, record the reading from both ammeter with the precision. Least count is 0.01 ampere and the voltmeter is 0.1 voltmeter. Perform the measurement quickly to avoid overheating. Repeat 2-3 times for consistency. This is the procedure we have to provide. This is for the 5 points in paper. Next question is explain how data from the experiment you described can use to answer question 1. And same for the question 2. We have to provide the question 1 and 2. Question 1 is this one. Do fewer electrons leave the bulb, entering the bulb, and potential difference inside the bulb? These two the main question. So we must measure the current using the ammeter immediately before enter and immediately after the bulb. If the reading are the same, no electron are eaten. Means same entry, same number of charges enter or leaving are the same. For the potential difference across the bulb, we need the voltage, essentially potential energy per unit charge. If the voltmeter reading is greater than 0, it means there is a potential difference. Mean electron losing potential energy when they pass through the bulb and converting heat or the light. So there is both answer. If the ammeter reading same, then we say the no electron is eaten or lost. If the potential difference is greater, voltmeter is reading greater than 0, that means the bulb is using energy. There is loss, there is a potential difference. Now the C part, if bulb is non-ohmic, if its resistance changes as a function of current, your setup part A is to set used or to modify to determine the whether bulb is ohmic or non-ohmic. A part C, if at all, does the setup need to modify for the non-ohmic check? What additional data, if any, would you need to be collected for these are for one point? Fourth, we have to design the experiment. This one, we say there is no change, physical wiring or strictly necessary to operate, check the ohmic or non-ohmic. We utilize adjustable power supply. We can change input power. Instead of taking one increment, we need to sweep through range of voltages. Mean if there is starting 2 volt, then we start with 3 volt, then we start with 4 volt, then power start from 0 volt. We are increasing the power step by step. Increment in steps, increase source voltage from 0.5 to 1 volt increment. Let's say each step pair of value. We have to find out the potential difference across the bulb and the current through the bulb, both two values. Collect 5 to 7 data points from dim to bright. Dim mean less voltage, bright mean high voltage. We are when we providing potential difference. Okay, D. How did you analyze determine whether the bulb is non-ohmic? Include a discussion how uncertainties in a voltmeter and ammeter would affect your argument for concluding whether the resistor is non-ohmic. Okay, we have come to know from the reading we count the bulb and the potential difference and the current measure in the modified experiment or previous experiment. We may have to make the graph as we shown in the fig. If the graph is a straight line, it is ohmic. If the graph is the curved one, then it is a non-ohmic. The straight line for origin, ohmic, non-ohmic for curve. If from the point of view slope, graph have different slope at different points, then a slope is r is equal to delta v by delta r. If r is constant, if at each point, each pair we get same r, it is ohmic device. If difference r is changing, then it is non-ohmic. Uncertainty analysis. We come to know that the ammeter have the uncertainty 0.01, voltmeter is 0.1. Then for the resistance, we come to know delta r. If delta r between the data point is much larger than the combined uncertainties, it concludes non-ohmic because change is real due to minor error. If delta is small within the uncertainty, it must be ohmic. Can't confidently say R change difference might due to the instrument error. So from value of delta R, we can define the either ohmic or non-ohmic. If the difference is much larger, then we come from the combined uncertainties, then we say it is the non-ohmic. If the minor, it is due to the instrumental error, so it will be the ohmic device. So that's the solution. If you have any query, kindly ask in the comments. Okay, take care.